buckle up, because today we are diving into a topic that has everyone talking. Hydrogen.
It seems like hydrogen is everywhere these days, doesn't it?
It really does. But I have to admit, I don't really get what all the hype is about. So we're doing a deep dive, going way past the basics.
Like fun.
I hope so. So to start us off, can you tell us a little bit about what hydrogen actually is?
Well, you might be surprised to learn that hydrogen is the most abundant element in the entire universe.
The entire universe? Wow, that's a lot.
It is. But here's the catch. We usually find it bound to other elements. Think about good old H2O water. It's when we isolate pure hydrogen that things get really interesting.
Okay, so it's not just about hydrogen existing, it's about unlocking its potential in its pure form. Where does our story begin?
Our story starts way back in 1766 with a scientist by the name of Henry Cavendish.
Cavendish. That name sounds familiar. Remind me, what was his claim to fame?
He was brilliant, but a bit eccentric. I mean, picture this. A scientist from a bygone era puttering around his lab in a powdered wig, no less.
Okay, I can see it now.
And he stumbles upon a completely new element.
Now that's a visual, so what did he find?
He discovered hydrogen, though he didn't call it that at the time, of course.
What did he call it?
He called it inflammable air.
Inflammable air? That sounds dangerous. Why?
Because it burned. But here's the really wild part. It burned cleanly.
Cleanly?
As in, no soot, no smoke, just water. This was a total head-scratcher back then, and it hinted at just how different hydrogen was from any other fuel source at the time.
That's wild. You'd think a discovery like that would have set the world on fire, so to speak. Why didn't people immediately ditch the dirty fuels and jump on the hydrogen bandwagon?
It's all about context. Cavendish's findings were revolutionary, but the science to really understand and harness hydrogen wasn't quite there yet. It's like finding a treasure chest, but you don't have the key to open it.
A treasure chest without a key. I like that analogy. So fast forward, and who picks up where Cavendish left off?
Fast forward a few decades to 1783, and another brilliant mind enters the picture. Antoine Lavoisier.
Okay, Lavoisier, now that name rings a bell. Wasn't he the one who cracked the code on what water really is?
Exactly. Lavoisier took Cavendish's experiment to a whole new level. In a demonstration at the prestigious French Academy of Sciences, can you imagine the scene? He meticulously proved that hydrogen, when burned, reacts with oxygen, and the only byproduct, you guessed it, is water.
That's incredible.
And to top it off, he even gave hydrogen its name.
Really? I never knew that.
It comes from the Greek words for, you guessed it, water forming.
Yeah.
Talk about a mic drop moment in scientific history.
It really was groundbreaking. So here you have this clean-burning fuel just waiting to be unleashed, and Lavoisier saw its potential back then. But then, as we know, the world went through the Industrial Revolution. Coal became king. Why the hesitation with hydrogen?
We have to remember the Industrial Revolution was a time of rapid technological advancement. However, environmental concerns weren't exactly front and center.
That's putting it mildly.
Coal was cheap. It was abundant, and the technology to fully realize hydrogen's potential was still developing.
So, while Lavoisier was envisioning a cleaner future, the world got caught up in the whirlwind of industrial progress.
However, Lavoisier wasn't alone in his forward thinking.
Oh.
Let's fast forward again.
Okay.
This time to 1874 to the imagination of Jules Verne.
Jules Verne. Now we're talking 20,000 leagues under the sea, journey to the center of the earth.
That's the one. But remember this one, The Mysterious Island.
Oh, absolutely. You're talking about the classic adventure novel.
In it, Verne imagines a future where water is split into hydrogen and oxygen to power a utopian society.
Wow.
It's remarkable how he foresaw a world running on hydrogen long before the technology was even remotely possible.
It's like these visionaries. They caught these glimpses of a cleaner future fueled by hydrogen. But the world wasn't quite ready to listen. Last time, we left off with visionaries like Lavoisier and Verne dreaming of a future fueled by hydrogen. But it seems like the world had other plans, at least for a little while.
Yeah, that's right.
Because fast forward to the peak of the Industrial Revolution, and it's pretty clear that those mountains of coal came with a pretty hefty price tag.
Yeah, you're right. And that price wasn't just measured in, economic terms, but in the very air we breathe.
It's easy to forget how bad things were when we're so used to seeing pictures of pristine Victorian architecture. But behind that facade was a city struggling to breathe.
Exactly. And it wasn't just London either. Think about it. Yeah. Industrial cities across the globe were grappling with the consequences of unchecked pollution.
Right.
And it really took a tragedy of immense proportions to kind of shake things up.
You're talking about the Great Smog of London in 1952.
Exactly.
I remember reading about that. This thick, choking smog that paralyzed the city for days. Can you imagine?
Imagine waking up one morning and the air is so thick with smog you can barely see your hand in front of your face.
That's hard to fathom.
And this went on for 5 days.
Oh my gosh.
The impact was devastating. Thousands of deaths were attributed to the smog.
It's hard to fathom the fear and helplessness people must have felt.
It was a horrifying event, and it became impossible to ignore the real cost of industrial pollution. The world was finally forced to confront the consequences of its actions.
And this is where things start to shift, right? The sense of urgency, the need for change, it kind of paves the way for the modern environmental movement as we know it.
Absolutely. The Great Smog was a wake-up call. It led to the UK's Clean Air Act in 1956.
One of the first pieces of legislation dedicated to tackling air pollution head-on.
Exactly.
Yeah.
And it was a turning point in how we view our relationship with the environment.
So we have this growing awareness of pollution, but then the 1970s hit, and the world is kind of thrown into chaos with the oil crises.
Right. Suddenly, energy security became paramount. The dependence on fossil fuels, which had seemed like the backbone of modern society, was exposed as a major vulnerability.
So it's almost as if those crises primed the world to start taking alternatives like hydrogen seriously.
You could say that. Remember John Bockris, the electrochemist we mentioned earlier? Well, the oil crisis really put his ideas about a hydrogen economy on the map. Bockris argued quite passionately that hydrogen, especially when produced from renewable resources, could power a cleaner, more sustainable future.
That's a bold vision, especially for a time when most people probably associated hydrogen with things like, the Hindenburg disaster.
Right.
Not exactly a selling point for a new energy source.
You're telling me. His ideas were considered radical by some, even outlandish. But Bockris was undeterred. He published books, he gave lectures, he tirelessly advocated for hydrogen as a solution to some of the world's most pressing energy and environmental challenges.
It's remarkable how often truly groundbreaking ideas are initially met with resistance. But Bockris's persistence, it paid off. His work really helped to reignite interest in hydrogen as a viable energy carrier.
Absolutely. He understood that transitioning to a new energy system wouldn't be easy, but he also recognized that the stakes were too high to ignore. He dared to imagine a future where we weren't beholden to fossil fuels, and he worked tirelessly to make that vision a reality.
It makes you wonder how differently things might have unfolded if the world had listened to those early proponents of hydrogen. But I guess better late than never, right?
Exactly. The journey of hydrogen is a testament to the fact that even the most revolutionary ideas, they often take time to gain traction. It's a reminder that progress isn't always linear. Sometimes it takes a crisis or a major disruption to make us question the status quo and embrace new possibilities.
It's a fascinating chapter in the story of hydrogen. We've gone from those early discoveries, some hesitant steps, to a world grappling with the urgent need for cleaner energy solutions. So we've journeyed through the history of hydrogen, from its discovery to its reemergence as a potential energy solution. But we've left out one pretty crucial detail.
What's that?
How do we actually get hydrogen? It's not exactly something we can, just scoop up.
You're right. It's a bit more complicated than that. Remember how we talked about hydrogen being bound to other elements?
Right. Mm-hmm.
Well, we need to separate it, and one of the most promising methods is called electrolysis.
Electrolysis. Okay, that sounds a bit intimidating.
How so?
Like something out of a Frankenstein movie.
Oh.
Break it down for me. What's actually happening there?
It's much less scary than it sounds. Essentially, we use electricity to split water molecules into their basic building blocks, hydrogen and oxygen.
Hold on. So we're talking about, essentially unmaking water?
Pretty much.
That's kind of mind-bending when you think about it.
It is amazing, isn't it?
But, okay, doesn't that require a lot of energy itself? I mean, are we kind of defeating the purpose of clean energy if we're using a ton of energy to produce it?
That's the million-dollar question.
Yeah.
And it all comes down to the source of that electricity. If we're using fossil fuels to make the electricity that then produces the hydrogen, well, yeah, that's a bit counterproductive.
Yeah, that feels like taking 2 steps back for every 1 step forward.
Exactly. To make hydrogen truly sustainable, we need to power that electrolysis process with renewable energy sources. Solar, wind, hydro. That's what makes green hydrogen so important.
Green hydrogen. Got it. So we take green electricity, we use it to split water, voila, we have clean hydrogen fuel. Now for the really exciting part, what can we actually do with it? Give me some real-world examples.
Well, how about powering a rocket into space?
Wait, like those massive rockets we see launching into orbit?
The very same. Back in the 1960s, the Gemini and Apollo missions used hydrogen fuel cells to generate electricity and even produce their drinking water as a byproduct.
So we're not talking about some, far-off futuristic technology here. Hydrogen is already part of our, space exploration legacy.
Precisely. And its potential extends far beyond space travel. You can actually walk into a Toyota dealership today and drive home a hydrogen-powered car.
Really? Those are commercially available now?
Well, yeah. The Toyota Mirai, which fittingly means future, runs on hydrogen fuel cells. It emits zero emissions, and you fuel it up just like a regular car, only with hydrogen instead of gasoline.
That's amazing. And it's not just cars, right? I've been hearing about, hydrogen-powered trains, too.
You'd be right. The world's first hydrogen-powered passenger train, the Coradia Island, is already operating in Germany. It runs silently, emitting only water vapor.
Wow.
Imagine cities with public transportation that's both clean and quiet. That's the promise of hydrogen.
Okay, I can already picture those, sleek, silent trains just gliding through cities of the future. This is amazing. Okay, so hydrogen can power our cars, our trains, even spacecraft. But what about those industries that are just notoriously hard to decarbonize? Those heavy hitters, things like steel production, cement production. Can hydrogen clean up those acts?
That's the big question. And the answer is, a hopeful maybe. These industries are just so energy intensive that they've traditionally relied heavily on fossil fuels, which makes them huge CO2 emitters. But imagine if we could replace those really polluting processes with ones powered by clean hydrogen.
I'm with you, that would be game-changing. But how realistic is that, really?
There are some promising developments already underway. Take the Hatride project in Sweden, for example. They're aiming to produce fossil-free steel using hydrogen instead of coal.
Fossil-free steel? That sounds almost impossible. What kind of impact are we talking about if they're successful?
The H-Wybert project alone could potentially slash Sweden's carbon emissions by a staggering 10%. And it's not just steel. We can produce green ammonia, which is essential for fertilizer, by the way, using hydrogen.
So we're talking about transforming entire industries from the ground up, all thanks to hydrogen. This is incredible. But let's address the elephant in the room here. Renewable energy sources like wind and solar, they're fantastic. But they're also intermittent. The sun doesn't always shine, the wind doesn't always blow. How can hydrogen help solve that critical storage problem?
You've hit on one of the most exciting aspects of hydrogen, its potential for energy storage. Imagine capturing that excess solar or wind energy and storing it as hydrogen to use later when the sun isn't shining or the wind isn't blowing.
So it's like bottling up renewable energy for a rainy day.
Exactly. This concept is called power to gas,
Yeah.
and it's already being implemented. Power to gas plants, they use that surplus renewable energy to produce hydrogen, which is then stored and used later to fill in those gaps when renewable energy production dips.
That sounds revolutionary. Are there any real-world examples of this working at scale?
Absolutely. Over in Falkenhagen, Germany, a power-to-gas plant is already storing wind energy as hydrogen and injecting it into the natural gas grid. Wow. And this isn't some small pilot project either. This thing can store enough energy to power thousands of homes for a whole day.
That's incredible. It seems like we're on the verge of a truly revolutionary shift in how we think about and consume energy.
I think so too. It's a really exciting time.
It really is. But before we get too carried away, you mentioned green hydrogen. Tell me more about that.
Oh, right. It's important to remember that not all hydrogen is created equal.
What do you mean? I thought hydrogen was hydrogen.
Well, the way hydrogen is produced significantly impacts how sustainable it really is.
Okay, I'm listening.
We've got gray hydrogen, which is the most common type. It's produced from fossil fuels
Oh.
without capturing the carbon emissions, so that's not doing us any favors.
Right.
Then we have blue hydrogen. It's also made from fossil fuels, but with carbon capture and storage, making it somewhat less environmentally damaging. But the gold standard, the one we should really be striving for, is green hydrogen.
Green hydrogen. Okay, so tell me, why does that one stand out?
Green hydrogen is produced entirely from renewable energy sources, making it the most sustainable option. However, it is currently more expensive to produce than gray or blue hydrogen.
I was going to say, there have to be some hurdles to overcome before green hydrogen becomes our, go-to fuel source.
Absolutely. Cost is a significant factor, but there is reason for optimism. As with any new technology, the costs are expected to decrease as production scales up and the technology improves. Plus, governments worldwide are beginning to implement policies and incentives to make green hydrogen more cost competitive. So, yeah, it's looking hopeful.
It sounds like we're at this really pivotal moment with the potential for hydrogen to truly reshape our world. Imagine a world where the air is cleaner, energy is more sustainable, and we're no longer reliant on those dirty fossil fuels. It's a future worth striving for.
It certainly is. It's a future where countries are cooperating to build a global hydrogen economy to ensure energy security and a healthier planet for everyone.
It's a beautiful vision and one I hope we can achieve. This journey into the world of hydrogen has been truly eye-opening. From those early discoveries to the cutting-edge technologies being developed today, it's clear that hydrogen has a vital role to play in building a cleaner, more sustainable future. And while it might seem like a far-off dream, as we've learned today, sometimes the future arrives faster than we think. Thanks for joining us for this deep dive into the incredible world of hydrogen. Until next time.